Geometry, trigonometry on the Cartesian plane. The Cartesian plane means we're talking about on an XY graph. Problem number one, find the angle between these intersecting lines. And for this one, we can be very precise on the graph and graph the first one. It has a y-intercept of -3. The slope is 3/4, so up 3 over 4, up 3 over 4. I'll do it one more time, up 3 over 4. And so here is our top line. Bottom line has a y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. The slope is -1/2, so down 1 over 2, down 1 over 2, down 1 over 2, and so forth. They are going to intersect right at that point. And that point is 8, 3. I'll call that point A at 8, 3. This point at the top I'll call point B is the y-intercept is 0, 7, and this point at the bottom I'll call C, that's 0, -3. The question here asks us to find the angle between the intersecting lines. I'll put that little marking on it, call this angle theta. Now we have this triangle formed by by these three vertices. We have these three vertices, so we can use the law of cosines to start solving this triangle. Because these are both y-intercepts, the distance between them is easy to calculate. It's just vertical, it's 10. If we use the distance formula on AB, it comes out to the square root of 80. And use the distance formula on AC, that also comes out to 10. Notice this is an isosceles triangle. They're not all going to be isosceles, so I'll show you the method we can use when it's not isosceles. So to find this angle, using the law of cosines, we'll say 10 squared equals the square root of 80 squared plus 10 squared minus 2 times the square root of 80 times 10 times the cosine of that angle theta. Now do the algebra, combine like terms and so forth, and we'll get that this angle is about 63.4 degrees. That is this angle, and that is a correct answer. Now there are 4 angles where these lines intersect. With vertical angles, we know these two yellow angles are equal to each other. You could have calculated this light blue angle, which is congruent to the one below it. The relationship between these two angles is that they're supplementary. So if you did 180 minus this, you could have gotten this other angle over here at about 116.6 degrees, and that would have been fine as well. You don't have to come up with both. It just says find the angle. Either one of them would have been fine. In order to find this other angle, maybe you could have used this point, point B, and the original point A to work on that triangle, but that's just preference. Next example, we have 2 more lines that are intersecting with each other, and I'm exaggerating them a little bit. This is 0, 4. It's the y-intercept of the top one. This point down here is 0, -6. It's the y-intercept of the bottom one. We need to figure out that intersection. And I drew this one really quick because they notice these two slopes are almost the same. They're almost parallel to each other. So their intersection is going to be very far to the left. It's not going to fit on any graph paper I have unless I really change the scale factor. So I'm just drawing a graph that's good enough, but I'm going to do the algebra to find that point. To do that, we'll set 2/5 x plus 4 equal to 1/3 x minus 6. See, they both have a denominator. So if we multiply them by the least common multiple, which would be 15, that will get rid of all denominators, allow us to solve for x. So distribute the 15, then do the algebra. You're going to get x equals -150. Super far to the left. Plug this x value into either one of those equations to get your y value. So I can plug it in up here, or I could have plugged it in right there. The y value comes out to -56. So now we'll have this point, -150, -56. I'd encourage you to pause and do the calculations. Find the distance between points A and B, B and C, and A and C. I'm going to write those values down here, though. This length is 10. This length is the square root of 26,100. And the length between A and C is the square root of 25,000. Use your law of cosines. 10 squared equals AB squared plus AC squared minus 2 times AB, AC, cosine of this angle. Do the algebra, take your cosine inverse, and the angle is going to be a very small one, only about 3.4 degrees. Here's our next example. We're going to take this point A and rotate it by 90 degrees counterclockwise around the origin. I'm going to draw a segment from A going into the origin. We have to rotate over by 90 degrees. It's going to look something kind of like this. And the nice thing about 90-degree rotations, or any multiple of 90, 90, 180, or 270, is that we're going to use a combination of these numbers with positives and negatives. So as I look into this quadrant, I see the point is around this area, negative 1, 2, 1, 2, 3, 4, 5, 6. The point for A prime looks like it should be negative 2, negative 6. Good news, the length of this yellow segment is the same as the length of that segment, which has to be true for these rotations. The point is equidistant from the origin, so those are equal, and this is our point. When you're rotating by 90 degrees, you flip-flop the x and y values. What was y becomes the opposite of that, becomes a new x value, and what was x becomes the y value. That's for 90 degrees. Question number 2 doesn't have a 90-degree rotation. Instead, it has the number of 110 degrees. So for this one, we're going to have to use some trig. Point B is at 5, 2. And then we're going to rotate it by 110 degrees. I'm just going to estimate a little bit here. I think maybe this looks like about 110 degrees. And we have to find the coordinates of B prime. Well, we're going to do a couple things here first. This length is 5, this length is 2. If you use Pythagorean theorem, this length is the square root of 29, which means that if we go out on this 110-degree angle, so here is our 110 degrees, go out the distance of square root of 29, that's going to be where B prime is located. Now, to actually figure this out, in this little yellow right triangle right here, call this angle theta, we can figure out the measurement of theta. Specifically, because it's a right triangle, we can use SOHCAHTOA. The tangent of theta is 2 over 5, so theta is the tangent inverse of 2/5, and that is approximately 21.8 degrees. That's all through the calculator. That angle is significant because you're starting at point B. It's already rotated 21.8 degrees above the origin, and then another 110 degrees. We can use that to help us figure out some information about this green triangle. Theta plus 110 plus this angle all have to add up to 180. If we've used up 110 in the middle, it means that theta plus this angle, this green angle, have to add up to 70 degrees. In other words, that angle has got to be 70 minus theta. So we did this on the calculator. We took 70 minus theta. That gives us approximately 48.2 degrees. And then I would store that on your calculator as B. Next, let's go back to this green triangle. This distance that we're traveling to the left from the origin is x. That's going to give us the x value of point B prime. And then this value that we're going up is the y value of point B prime. So in this green triangle, we have this angle B. It's a right triangle. We know the hypotenuse is root 29 because it has to be the same distance from the origin as the original. We could say that the cosine of that angle that's stored in our calculator is equal to the adjacent divided by the hypotenuse. Multiply both sides by root 29, evaluate that, and we're getting x to be about 3.59. But if I look at the drawing, it's going to the left, so the x value should be negative 3.59. So in the context, I know that. To solve for this y value, we're going to use a different trig function. From this angle, y is the opposite, root 29 is the hypotenuse. So the sine of b is equal to y over the square root of 29. Multiply both sides by root 29 and evaluate that. We get y is about 4.01. Now, if you wanted to check this answer, you could use Pythagorean theorem on this, 3.59 squared plus 4.01 squared, and that should come out to 29. Pythagorean theorem still should work. Here's question number 3, and I'm not going to show as much work on this one. Point C is at 2, 7, and it's going to be rotated by 40 degrees counterclockwise around the origin, so it's going to end up somewhere over there. In general, what you're going to do is the same process. This is 2, this is 7. Use Pythagorean theorem to find that length. Use SOHCAHTOA to figure out that angle theta. If this is 40 degrees in the middle, we're going to take 140 minus this angle theta to get this angle. And we have a triangle over here. We know the hypotenuse is going to be the same as the hypotenuse from the original. And x and y, the x value is negative because it's to the left. I would pause this to do the calculations. And the answer, the coordinates for point C prime, going to be negative 2.97, comma 6.65.